Hello, welcome to a video that will cover systems of linear equations for the SAT exam. And here we're looking at practice set 2. So what we're going to do is we're going to do 3 problems, one easy, one medium, one hard. Again, the hard ones are not really that tough, just they're presented a little bit oddly. So let's start with an easy one. So let's look at number 1 here. And I'm going to copy and paste this and put this in a program that will make it really easy for me to scribe. So here they're asking you to solve for y. Now if you see a system of linear equations, in this case here, there's a few techniques you can use. You can use substitution or elimination. There's actually some other ones as well involving the matrix, which some people probably don't learn, or you can graph. But we'll use one of these two, substitution or elimination. Now, a calculator symbol is not shown here. It means you can't use a calculator. There are some programs in these fancy graphing calculators that can do this for you in a matter of seconds, but the College Board is very clever with putting a question like this in a non-calculator section because they want you to do the algebra. So let's try substitution. That seems to be a popular technique with a lot of algebra students. So you can isolate one of the variables. Say I get x by itself. And you'll see why I chose to get x by itself in just a sec. So x equals 29 minus y. And then what you do is you replace x with 29 minus y in the other equation. So I took the first equation, isolated one variable, and then substitute that into the other equation for that variable. And the reason why I got x by itself is because the question is asking for y. So why not solve for y directly and be done with this? 29 plus y equals 12, y equals negative 17, and there we go. So the easy problems, the ones that are usually in the beginning of the math section, shouldn't take very long. So if you're spending too long on it, you're probably overanalyzing it, or maybe not thinking about it correctly. So this should be reassuring that we're getting quickly. On the flip side, when you're working on the more challenging ones at the end, if you're getting too quickly, you might be oversimplifying it, and so we have to be mindful of that. Oops. So let's go to a medium level problem, and word problems are always good ones to look at. So let's try what the heck, let's do number 11 here. It's always good to look at wordy problems because those can be a little bit weird. And then let me copy the choices. So it seems as if they're giving us some sort of situation, and we're going to have to match a system of equations to the situation. But let's read the problem first. The most popular item at a bakery are its raspberry scones and lemon poppy seed muffins. Yeah, I don't care what's popular at a bakery. So let's just get rid of that. We want numbers, right? The shop sells both items in boxes of 12 at a cost of $15 per box for raspberry, okay, $9 per box for lemon poppy. Friday and Saturday, the shop earned $396 by selling a total of 46 boxes, okay. If R and L represent the number of boxes of raspberry and lemon poppy seeds, okay. Sold over the 2-day period, big deal, I don't care if it's over 2 days. Which of the following equations could be used to find the number of boxes? So they want to find the number of boxes of each type, right? And it looks like they're using R and L for raspberry and lemon, respectively. So we want to solve for R and L. And also the fact that there's 12 in a box, who cares either? That doesn't matter. So we want to filter out information that's useless. What I have circled there, $15 per box for raspberry, $9 per box for lemon poppy, you make $396, 46 boxes are sold. In business, that's all we care about. We want to make money. So who cares about the 2 days and 12 in the box? This is silly. So how many boxes did I sell? Total boxes was 46. So I come up with a verbal model, and R plus L, of course, is going to represent total boxes. So R plus L must equal 46. That eliminates B and D. Notice they put those 12s there to really mess with you. Don't let that happen. R and L are strictly the number of boxes of raspberry and lemon poppy seed muffins, respectively. So for 46 boxes, R plus L is 46. Then the money. So I'm charging 15 bucks for every raspberry scone. That's very expensive, but it better be delicious. But it's okay. Lemons, poppy seed muffins. Yeah, lemon poppy seed is usually the redhead stepchild of muffins. No one really likes those, so they're probably cheaper. Sorry for extra information you really need to know, but that's what happens. So they put the 2 there and see to kind of mess with you, the 2-day period. It doesn't matter. We're just trying to find the number of boxes of each one. So the answer is A. And again, which of the following? Process of elimination. I'm looking at the choices, see what makes sense. So that's that one. Lastly, let's try 19. Here calculator is allowed, but calculator not going to really help too much. So in this case, they're asking what does k have to equal, so there's no solution. Just so you know, to get no solution, you're going to have some equations up here. And when you combine the equations, you're going to want 0 equaling some non-zero number. That's what we're hoping to get. So let's take a look at this problem. 11x minus 24y equals 8, kx minus 36y equals 5. Substitution is going to be kind of tricky. Not a good fit. That's because no coefficients equals 1, meaning that you'll get some wacky fractions if you try isolating one of the variables. I wouldn't recommend that. Instead, let's use elimination. And actually, we could just probably work over here. So what if I could try getting rid of y and multiply this by 3 and multiply this by -2? By doing that, you're going to have a 72 next to y for the first equation and a 72 as well next to y in the second equation. Actually, it's -72 for the first equation. So you get 33x minus 72y equals 24. Here you get -2kx plus 72y equals -10. And let me see if I can lasso this. Okay, I did a pretty terrible job of. I think it might be okay. I need some help with my lassoing skills. Maybe copy and paste it. There we go. Perfect. So if I add these two equations together now, see how the y's cancel, so you get 0 for that, 14 on this side. And you want 0 over here. You want these to cancel in order to get no solution. So 0 equals 14. Of course, it's not a true statement. That doesn't work for us. K would have to be -16.5 to make that work, because 33 plus 2k is going to have to equal 0. 2k equals -33. K is -33 over 2. So if k were -16.5, things would cancel for us. And actually, I lied. That's a -2kx. So that's actually -2k. So it's positive 16.5. I knew that was wrong because you can't grid negative numbers. So I knew I made an error somewhere along the way. So 16.5 would get us no solution. And so that's something with a system of equations that we'll need to be familiar with. What can result? What has to happen in order to get no solution? Okay, that covers a video on linear equations.